Hello everyone. Now we are going to discuss the next topic, that is underdamped systems. So this is the third part of the damped system. We have classified the damped system to three categories. The first is overdamped, the second is underdamped, and the third is critical damped. We have completed overdamped and the critical damped system. Now it's time to discuss about the underdamped system. That is the last one. So I'm just writing here the first. We all know that the roots of the equations are alpha 1 2 is equal to minus of zeta omega n plus minus iota under root of 1 minus zeta square multiply omega n. Okay, here this term, this is the term which represent the omega d which is constant. This complete terms multiplication of iota represent the omega d. Okay, so the roots becomes alpha 1 2, that would be equal to minus of zeta omega n plus minus iota omega d. So this is the roots of the equation. So now when you put this value in the equations, you will get the solution. And we all know that the equations is nothing but the equations of the damped system, that you can refer from that video, previous video. So the solution will be x is equal to, we know that the solution is x is equal to a into e to power alpha 1 t plus b multiply e to the power alpha 2 t. And we all know the value of alpha 1 and alpha 2. You just have to put this value here. So I'm just putting here. We have to do this carefully. There will not be any sign convention mistake. E to the power alpha 1. Alpha 1 means minus of zeta omega n plus iota under root of 1 minus zeta square omega n plus sign I'm going to consider first. Okay, or you can write it as omega. You need not to write this whole term, you just have to write down it as omega d. This is iota omega d multiply t plus, similarly you just have to put the value of alpha 2 e to the power minus of zeta omega n minus iota omega d multiply t. Okay, so now when you rearrange this equation, you have some value. That means I'm just rearranging these equations. So it would be x is equal to e to the power minus of zeta omega n multiply t bracket a plus b cos of omega. See, this is a procedure you will study in the mathematics differential equations. You need not to worry about it. Okay, so basically these are the topics which you study in the mathematics subject. So there you will learn how to make the solutions of the equations of the differential equations. Okay, so this is I'm just writing here because the result is very important for us. Okay, so here e to the power minus of zeta n into omega n into t, that is you can take it as common. So a plus b cos of omega dt plus iota a minus b sine of omega d t. Okay, so this would be this would represent as, this term I am representing as cos phi, x cos phi, and this term I am representing as x sin phi, Okay, so the equations. So now the final equations that we'll get here, the final equations would be x is equal to, this is a small x. Okay, this is a small x, that would be equal to capital X e to the power minus of zeta omega n multiply t sine We know this is the formula that sin A cos B plus cos A sin B, like that. So you just have to write it down as sin omega dt plus phi. Okay. So this is the mathematical calculations, nothing else, where x, capital X and phi is constant. Capital X and phi are constant here. This is the magnitude. See, this is the magnitude multiplication of sine omega t plus phi. This is capital X multiplied into the power minus zeta omega n into t, that represent the amplitude. Okay. So, and this is CF. We study in the mathematics CF and PI, particular integral, like that. So that would represent the CF. So now this CF value you will get in the underdamped system. And if you want to know the frequency of the vibrations, so here this is the equations. That's very important equations. You must learn this. And vibrations with the frequency, you must learn what is the frequency of the, because we are discussing the damped system. Okay, we are not discussing the natural vibratory system. This is the damped vibration system. So in the damped vibration system, vibration with the frequency of, what is the frequency? You can see here, frequency would be represent as omega d, that would be under root of 1 minus zeta square multiply omega n. This is the frequency, vibration with frequency, that means this is the frequency of damped vibratory system. Okay, this is the frequency of damped system, and omega n represent the natural frequency. We all know that, and omega d is also constant. Remember that omega d is also constant because omega n constant, and zeta, which is representing as damping ratio and the damping factor. Okay, so we know that in the underdamped system, in case of underdamped system, the zeta value is less than 1. So that means when you put the value of zeta which is less than 1, you will get the positive value here. Okay. So here, if you want to calculate the time of oscillations of damped system, that would be calculated as 2 pi upon omega d, which is also constant. And if you want to calculate the frequency in hertz, sometimes examiners will ask you the frequency in hertz. Remember that if examiner asks you the frequency, you have to check it the frequency of natural vibratory system or the damped system. Okay, this is the important. So this is the frequency of the damped system. That means that would be as omega d upon 2 pi. That is the frequency of the damped system in hertz. And this is in radian per second. This is in radian per second. So I hope you will understand this complete procedure. But we have seen this is the frequency of the damped system through these equations. This is the important equations of the underdamped system. I am just showing here. We have calculated the value of omega d. Okay. Now what is this? What this whole term represent? Basically, this whole term represent the amplitude. And you can see carefully, this is the time exponential functions that represent that this amplitude is going to be decreased with the time, because it is a function of time. But here minus sign denotes that as time increases and as time goes on, there will be a reduction in the amplitude. So that means there will be an amplitude which is x into the power minus of zeta omega n into t, which decreases with increase in the time, with the function of time, because it is a function of time. We all know that, but the negative sign is there. That's why it is decreasing with the time. So when you draw this on the diagram, you will find out the diagram is like that. So I'm just showing you here the diagram. This is a rough diagram. You can draw it using scale, because it is an exponential functions. So it would be like that. Initially it will decrease, and after some times it becomes constant, like that. Similarly, it will comes like from here in the downward directions. So it will become constant after some time. Are you getting my point? So I hope you will understand this here. And this is the time, basically it represents the time. But we are discussing about the damped system. Remember one thing. We are discussing the damped system. This represent the x naught. This is represent the x naught, and this whole graph is the amplitude, that means x into the power minus of zeta omega n multiplied t. Okay, this is the amplitude graph, and there will be a time interval. This is the first time interval. This is as td, and this is the second time interval, that is 2td. Okay, so here the graph would be like that, and this would be minus sign will be there because in the down direction there will be a minus sign. I'm going to consider minus x into the power minus zeta omega n multiplied t. So this is basically the amplitude of the vibratory damped system. Okay, so at t बराबर 0, at t बराबर 0, amplitude is x naught, and when you put the value of t बराबर 0 in this equations, in this amplitude value, you will get the value capital X. So x naught will be equal to x sin phi. Sin phi means this is x is equal to x naught, and we know that at t बराबर 0, this will become 0, and that means e to the power 0 is 1. Okay, so there will only be capital X will be there. So and x बराबर x naught, that means x naught is equal to x multiplies sine. This will become 0 because at t बराबर 0 we are calculating, so there will be a sin phi value. So we just have to put the values in this equation. Basically you can write it as equation number 1. So you in the equation number 1, as you put the value of time, you will get the different value. So at t बराबर td, you will get the value of x1, that is x e to the power minus of zeta omega n td multiplies sin phi. Similarly, you can find out any value. Next is if I put t बराबर 2td, there will be amplitude value x2. Equations would become x2 is equal to capital X e to the power minus of zeta omega n 2td sin phi. This is the CF value. Okay, now similarly you can find out the different values by putting the different time interval values. So you will get the decrement ratio. We will discuss the next topic, decrement ratio, where you will see how to use this x0, x1 and x2 different way, and from where we will calculate the logarithmic decrement also. That's an important from the numerical perspective. So everything must be clear here. There must not be any doubt here because this is whole the mathematical procedure. This is completely a mathematical procedure. Okay, so thank you.